This is microservice orchestration. One of the problems that I've often experienced in the past is to put up a proper development and DevOps linked architecture. This often requires that DevOps people and developers actually live very close together in terms of what they're doing. This is based on some experience that I have where I had a large number of microservices that needed to be deployed and developed on at the same time. So let's have a look at how this works. What is a typical team, dev and DevOps? First of all, you need to get developers to work as the software is deployed. What does that mean? So developers work on their laptops. They need to have access to live clusters, live being active clusters, and only the build configurations should be changed. Developers need to develop on a personal machine in microservice mode. They need to run local containers for current work, whether that is normal Docker or Docker Compose for various bits, right, or whatever other environments they work. Whereas your cluster would probably in the modern world be working on container D and various other container configurations. And obviously developers run into big trouble when they're trying to run all the containers that they need locally, especially if they've got Fabric databases living on the cloud somewhere, and they cannot run all their containers locally. So they need access to other microservices, complete or in a semi-complete state, somewhere for them to run, because no microservice development happens in isolation. Yes, you develop the microservice to be an isolated piece of software, but it needs to interact, whether it be via some other API call or other ways. It needs to interact with the microservices that are already in development or have been developed or are deployed already in some other guise. Obviously, you don't want developers to work in live spaces. So we've got to do this, and we've got to assume that you're going to be working remotely. DevOps and site reliability engineering or engineers need to test core environments and deploy code. That's their requirements. Okay. So core example. Core environments are things like RabbitMQ, Redis, Vault, Keycloak, etc. Those are services used by the software that an organization is developing. Code is developer-related code, corporate IP, and this needs to be done in a seamless way. So how do we do this? Let's say we've got developer A. He's currently working on say, a Docker Compose or a Docker container, and he's got maybe one or two of those that he's working on at the same time, depending on how it works. And you've got developer B who's remote in a different location, and you've got up to developer N. So you've got N number of developers that work in the environment. They have access through the correct structures into wherever their containers live. They commit code into various GitOps repos, whether that be GitOps itself or GitHub, or it doesn't matter which one of those repos it actually does. Then we'll have clusters out there. Now, I like this concept of a best build cluster. A best build cluster is sometimes used by testing teams, certainly developer testing, but mostly this is where we've deployed code that we have written or in the process of writing or in a semi-complete state that can be utilized by a development community. And these have got formal microservices deployed. As I say, some of these may be in Docker, some of them may be in container D. It doesn't really matter what they are, but they're formal microservices that have been deployed. And some of these may only be in a test state at the moment, right? And some of them will be in a development paradigm, right? There's a really high iteration of deployment over there by the DevOps team, and other team members commit these microservices into the environment. This goes through a continuous integration and continuous deployment process, naturally by your DevOps team. The most important consideration over here is to start off by building a proper gateway. To have a proper gateway in the environment, and this is called a patterned gateway. It's not a gateway as many people may be thinking of a gateway, but it's usually a piece of software that you develop yourself, whereby you can route software to various microservices depending on their states and their level of completeness. Developers then access this gateway from their containers that they're currently working on to be able to integrate with the formal, the test, or other in development containers as they go along, and that's normal for the group consolidation. Your DevOps people access the various Git repos, depending on the status and the branches and all those type of parameters. They then do a deployment through the CI/CD on a continuous basis, right, to get the deployment done. I'm going to leave this up on the screen for a little while, talk to some of the other things for you to have a look at. So I like to work with what we call a best build cluster in environments where you have a high amount of development happening all the time. This is the kind of environment that you need to put together. Other clusters may be test clusters, proof of concept clusters, but it doesn't really matter. And these clusters would probably be accessing some kind of database on the Fabric environment or not. Okay. That's pretty much it from my perspective in terms of a preferred development architecture. Thank you very much.